So let me give you a hypothetical. I want you to imagine a 6-mile long stretch of water. This water is straight and level and does not flow.
Advanced simplicity takes hold. You find the truth from things of old.
So let me give you a hypothetical. I want you to imagine a 6-mile long straight stretch of water. At each end of this straight stretch of water is a bridge. Point A, so you've got 2 bridges. Point B, this water is straight and level and does not flow. At each end of this water is a bridge. Point A, point B. At each bridge there is a plumb bob hanging down to the water.
We are on the road,
even altitude,
suspending judgment until the truth is known. You will find peace within.
Let me give you a hypothetical.
In the midst of all these troubled souls.
Now, on these vertical strings, can you imagine an even altitude? A point at an equal height above the surface of the water below.
Advanced simplicity takes hold.
An even
You
altitude.
find the truth from things of old.
And on these vertical strings, can you imagine 2 points? So let me give you a hypothetical. Can you imagine point A and even altitude at these points and point B? And on these vertical strings, we can establish a perpendicular and even altitude and call one point A and the other point B. 2 points. Point A, point B, even altitude.
We are on the road,
2 points.
suspending judgment until the truth is known.
Point A,
You will find peace within.
point B.
In the midst of all these troubled souls.
The point at an equal height above the surface of the water below. Point A, point B. Point A, even altitude. Point B.
There's no end game in mind.
Is the shortest distance between those 2 points?
It's only the truth that we seek to find.
We know the shortest distance
There's no end game in mind.
between 2 points is a straight
It's
line.
only the truth that we seek to find.
Now, here's the question I'm asking myself. How can the distance between these 2 points be anything other than horizontal? Horizontal.
Everyone must see it for
Horizontal.
themselves. The truth
2
is there
points.
for you to find.
And then ask yourself, and the water? Oh, fuck that up.
Hello, everybody.
Oh yeah.
I think it was J. Rowe who invited me. How are you folks doing? I didn't get to hear most of today's show. I heard a few minutes at the beginning, but I was working on a project, so.
That's it.
I was just
what's
hanging
that?
out.
Is that a thing that Jeranism or a comment on it? What do you think about the arguments going on in Flat Earth? Suppose you're right in that, right? It's like they're ending it. Or like there's only one true flat earther.
Who would that be?
Don't know. I don't know. They're all like trying to educate each other at the minute. I think it's much like our friend Flat Earth Mathematics here.
Hey, a mild change of subject. I just wanted to say this very quickly to Buster. The last time we spoke, you were talking about the the two ends of the bridge and then the one in the middle, and then would I be able to find the distance in 3D space of the X, Y, and Z coordinates? And so I got the 2D part, and it literally took a page of algebra to derive a formula to find the distance from a point to a line, given 2 points. So I wanted to say that I definitely have made progress on your challenge. I haven't forgotten about you, Buster.
Yeah, no, I appreciate that. Are you familiar with a theodolite?
Yeah, only passing. I mean, my understanding is that you can very, very accurately find horizontal angles and vertical angles, but not much more than that.
But like, as far as like first principles of what the instrument it is, like you'd set it up properly, and you could, if you within that X, Y, Z coordinates, so you'd have your X and Y, that horizontal azimuth. Then you'd have your Z, the vertical. And so that instrument at that point, you set it up properly, you'd have that, right? The Cartesian.
My understanding, Buster, and if anybody else can correct me if I'm wrong, because I have not used a theodolite, but my understanding, Buster, is that there's no X, Y, and Z theodolite use. It is purely angle relationships. There's a horizontal angle and a vertical angle, and you might be able to translate that later on into Y's and Z's, but the theodolite does not have a distance measuring capability, so you wouldn't really be able to know, how far something is unless you took multiple measurements from multiple locations.
Well, yeah, but you could physically measure it as you're using the instrument.
Yeah, well, the thing is with land surveying, the whole principles of land surveying are based upon that if you have a triangle and one of the lengths of triangle and two angles, then you could find the other two sides and the remaining third angle. But if you have a theodolite at one location, the only thing you can measure with that one location is just vertical angles and horizontal angles. That's my understanding.
Yeah, but you can measure distances as well, right?
Without moving the instrument, that's correct. You wouldn't be able to measure distance. But
No,
obviously,
no. You're not limited to just the theodolite when you're doing surveying in reality.
Right. You're the world is your oyster. You're doing surveying. You're allowed to walk around the field. You can't you're not stuck in the corner. It's just a theodolite, and you can't get out of theodolite prison. But yeah. So if you move the instrument, you make multiple readings. Sure.
But if you've got the instruments, it's set up properly. You wouldn't say that that's X, Y, Z.
No, that's just my understanding. No.
But wait, so like if it's set up properly, the instrument can spin, and that's where you get the horizontal angles.
Right, angles, but not distances.
Yeah, but that's the XY.
You could say it's the XY plane, but you're only placing angles in the XY plane. So that's,
Yeah, but it's the XY plane.
Azimuthal plane.
No.
So you would say,
Yeah, so like that's the XY plane that instrument is in.
Yeah, like I said, I am not a surveyor. I've never touched a theodolite, but my understanding is that when surveyors are out in the field, they're not talking about X, Y's, and Z's unless they have a GPS receiver is getting that data on the ECEF coordinate
But what
system.
if you can't get a GPS reading?
Oh yeah, well, land surveyors, existed hundreds of years before there was GPS. So, but any kind of land surveying, my understanding was all done with triangles, where you needed to have some kind of a baseline, some kind of a length that was precisely known, and then you would place a theodolite at each end of that length, and then measure angle measurements, and then you can draw all sorts of conclusions, including distances.
Yeah, but like that's the point. Like you get an angle, so on the horizontal azimuth, you can get an angle, right?
Yeah.
Yeah. So if I wanted to get a 90-degree on that horizontal, I could acquire that with a theodolite.
Yeah, absolutely. But all I'm saying, Buster, and all I'm saying is that I just don't think that surveyors don't talk in terms of X, Y's, and Z's unless they're using the ECF coordinates. That usually requires
what's
GPS.
what's ECF coordinates?
Earth centered, Earth fixed, or something. I'm not 100% sure, but those were the coordinates that, like, the GPS that Jesse drove over the bridge. Like, that was the original question that you had for me. Was, it was X, Y, and Z, a point at the beginning of the bridge, X, Y, and Z over the middle of the bridge, and then X, Y, and Z over the end of the bridge. And then those 3 points were not collinear. So,
It's called ECEF. ECEF.
okay, and then does it stand for Earth centered, Earth fixed?
Yeah.
Okay, like I said, I'm not a surveyor, so
I'm not either. But we can talk about these things, right?
yeah. I'm just trying to make sure that I'm not misrepresenting myself. Like I'm what I've seen on TV.
It's about trying to understand, like, gain an understanding about something. That's like you want to acquire knowledge on something.
Yes, absolutely.
Yeah. And we're just like, I'm totally talking about the rudimentary functions of what these instruments do. We're not getting super like that. The whole bridge thing, that's something that's like, I mean, I don't know. Like, if you figure that out, that, like, good on you. But, like, for me, in my experience, watching people use those theodolites, they do, they use like a grid system. So, like, the X, Y, Z. So the people I've seen use them, they actually hang a plumb bob as part of the setup.
Yeah, I mean, you're not equating, or you're not trying to equate Jesse driving over the car with the thing on the roof of his car to a theodolite, are you?
No, I'm absolutely not. I was the only reason why I mentioned that, Bev, was that it was a computerized receiver, transmitting and receiving from satellites, getting X, Y, and Z on the ECEF coordinate system.
Yeah, it's just plotting points.
Yeah, well, then that's where the 3 coplanar points come from. I know you like to say 3 coplanar points.
No. Oh, Bev. Yeah, I was gonna say Bev only said it because Jesse said it.
Sure. But I mean, I think the reason why I think it's a joke is that the plane that he's talking about.
Jesse said it.
I know, I get that. But it's turned into a meme. No, it's turned into a meme, kind of like Tis Globe. The thing that I think that you guys are getting humor in is that the 3 coplanar points, the plane is the vertical plane, not any kind of a horizontal plane. So he's got 3 coplanar points.
You think that's a vertical plane?
That's
no,
a
it's a vertical plane.
You can't have a vertical plane, can you?
Yes, you can.
What? But you're saying it's not a horizontal plane?
That's correct.
But you
There's
can't
no horizontal
have a horizontal plane, right?
Yes, but that does not include the 3 points, the start, middle, and end that he was talking about when he said 3 coplanar points.
Okay.
He was talking about a vertical plane, and that's why I think it's funny that you guys make a joke about it.
Brilliant. So perpendicular to that vertical plane would have a plane that goes from point A to point B at each end of the bridge. Right?
You could
now you're saying that that horizontal plane that is perpendicular to the vertical plane.
I never called it a horizontal plane.
No, I'm calling it a horizontal plane, right? Perpendicular to the vertical plane that you've just called, right? I'm calling that horizontal because it is perpendicular, and it would have the point at each end of the bridge, right? You'll give me that mathematically.
I'm following along with what you're saying, but I am not going to call it a horizontal plane. That would not be a horizontal plane.
Well, here we go. You've got a vertical plane. You claimed that Jesse Kozlowski claimed 3 coplanar points on a vertical plane. Now,
yes,
I'm saying
absolutely.
A horizontal plane perpendicular to that vertical plane that has points at each end of the bridge.
Yes, I understand what you're saying.
Now,
so
you're saying
please continue.
The middle point would not lie on the horizontal plane.
Right. I just disagree with the name of
And
the
there
plane,
would
but
be
yes,
there
the middle
would be
point
a
would not
vertical,
be in that.
a vertical distance
Yeah.
from that horizontal plane
Yes,
for the
I just disagree with
midpoint.
the name. Yes, that's would be the Sagitta,
Okay, so
and it's like I don't
the
know,
height
90
of
feet or
that
something.
vertical diff change is a vertical. It's on the vertical, right?
Yeah, well, it's a
So
distance in the
therefore,
vertical
it
plane.
would be a distance on the vertical plane, on the vertical datum change.
Well, you're throwing in the word datum and you're throwing in the word horizontal plane. I disagree with those
Why?
words.
Well, you
It
just
using pure
you claim the vertical plane.
right.
So
But I don't claim the
perpendicular to a
horizontal.
vertical plane would be horizontal.
No.
Why not? Vertical and horizontal are perpendicular.
Okay. The rule is you have a
Betty's logic.
plumb. No, the rule is you have a plumb, a vertical line. If you have a vertical line, anything you construct perpendicular to that will be horizontal.
So plumb
Horizontal lines, horizontal planes, but you can't do this long 26-mile distance and construct a horizontal plane. You just
You've
can't
made
do
a
that.
vertical plane.
But you can have a vertical plane, 25,000 miles, in area.
Well, so perpendicular to that
No,
would be
no,
horizontal.
no. The only thing you can make a perpendicular to is a plumb, and call that horizontal.
So
That's
wait,
what I was saying. There's
so
no
I just need-
exceptions.
I just one clarifier.
Sure.
You'd say plumb is vertical.
Yes.
Okay.
And those three coplanar points, you could line up three plumb bobs, and they would all be within that vertical plane, right? On that vertical.
But they would be diverging from each other.
What do you mean? No, they would
No,
all
they
be
would
on
be-
the vertical plane.
They would all be on the vertical plane, but
Okay.
they would be diverging from each other by about a third of
They're
a degree.
diverging on the vertical plane. Whilst being
No, well-
on the same vertical plane, you're saying they would be diverging from the
Each other.
vertical?
Yeah. The plumb bobs, the string of the plumb bobs would all be coplanar. So you have three plumb bobs, three strings, all of them coplanar. Okay? But the actual orientation of the plumb bob, looking from the side angle, the Muppet vision, would be diverging by about a third of a degree.
You'd never see that.
We were just talking about this.
Of course, it's impossible to see.
Exactly.
That's
Why
one
are
of the-
you claiming it then? You're
because
claiming
I
an
know the shape of the Earth.
impossibility.
Oh no,
Charles.
I'm saying that the only thing that I claim would be impossible is measuring a third of a degree deviation from a string of a plumb bob to another string of a plumb bob, 26 miles away or whatever.
Sure, there's some
that's what I'm
claims
saying.
of thousandths of a 3,600th of a degree. You're saying that's not? Are they making that shit up?
No, I'm saying the the measurements of, for example, surveying measurements that can determine Earth's curvature do not involve measuring deviations of plumb bobs. You could
What?
do
Wait, say
reciprocal
that again.
zenith angles.
Wait. Do you know? Have you heard of a guy that may possibly live in Maine?
Yes, and he may possibly be a surveyor. Yes.
Okay, and have you heard of the distance that he supposedly did it? I think it was around about 500 meters.
Yeah. I've talked to Jesse about that as well. Jesse's done it. I think in as short as 500 meters, he's measured Earth curvature.
What do you mean, Earth curvature?
Well, because the Earth is a globe,
We're talking about
so-
verticals, right? We're talking about plumb bobs, and you've just said it was impossible to do it.
I'm
but
saying
you've got
okay, you gotta
people
be-
that probably don't live in Maine claiming to do it, and now you're talking about Jesse Kozlowski
Okay, so
doing
let's
similar
let's,
sort of things. But you've
let's back up.
just
Let's back up a
claimed
second.
Impossible.
Let's back up a second. As long as we're crystal clear on
Back
what
up
I said
to the
was
bit where
impossible.
you said it was impossible, right? Let's start
Well,
there.
let's clarify what I said was impossible. If you hang two plumb bobs 26 miles apart, what I claimed was impossible is literally measuring the deviation of the strings of those plumb bobs, not using any other instruments, not using theodolites, not using anything, literally just somehow determining that the string of one plumb bob is between a
Okay.
third and a half of a degree
Forget about
deviated
that
from a
then.
string of another
Let's
plumb
go
bob.
to this 500 meter one that Jesse Kozlowski and the guy that probably doesn't live in Maine.
Yeah, I forget when I was talking to Jesse about it. I said, "What's the shortest?" He says, "He's done it in a parking lot," and what he said was what he meant was measuring Earth curvature. I don't know exactly how, using what surveying technique. So I'm not the expert here, and I can't speak
But
for.
you just blindly believe it?
Yeah. Well,
No,
even
I
though
don't
you
blindly
just said
believe
it was
it.
impossible, right? But Jesse Kozlowski
measured-
said it. So I mean,
I've measured the shape of the Earth myself in multiple different ways. So I can confirm 100% that the Earth is a globe. I've never used surveying instruments to do it. I use other means. But so it's not a blind belief. I absolutely 100% with 100% of my data gathering know the Earth is a globe.
yeah, we can do that. We can all do that, right? His
Yes,
globe,
that's what my
right?
channel is all about.
Yeah,
No,
yeah.
not his globe.
Yeah,
Go
it's his
outside and make
globe.
careful observation. No, that's a silly meme.
What do you mean? It's not a silly meme. It's a.
It's a silly meme. It's what people post anytime I say the Earth is a globe. People are like, "This globe," and there's that funny black and white guy. No, to answer Buster's question it is not a blind belief I have. It is one that is from numerous field observations, predictions that I've made. I've
Right, but
literally
we
figured
are
out-
talking about the plumb bobs here, right?
Sure, and that's what
well,
I said was impossible, is
how
measuring the
good-
deviation of the plumb bobs.
How good
Okay.
would you say
String.
your critical thinking skills are?
Excellent.
Sorry?
Excellent. I'm one of the few globers that actually has been casting a cocked eye towards all this stuff in the last 3 years. The worldwide medical event, which we will not name.
No.
I'm like the only glober
No.
event
We're
that
talking
I know.
about Jesse Kozlowski. You
So
believe
it's like
anything
I'm critical
he says.
critical
That's not
thinking.
critical
Yes,
thinking, is it?
I'm not I'm
Just
just saying
reasonings-
that I don't just accept what the authorities tell me.
No.
That's
I
the
wasn't
point
going
for
down
me.
I wasn't going down that road. Like, how good would you say you have a reasonably good critical thinking skill?
Excellent.
Okay, excellent. So earlier I was talking about the functions of these instruments and just the geometry involved.
Yes.
Like, you think you could use your excellent critical thinking skills to work out how they work?
Yes. Yeah. I mean, to it, you're asking me to spitball something where there's literally people who have trained in it, and I have not trained in it. So it's like,
All right, yeah.
the big asterisk, because I am not a surveyor. I've never touched a theodolite, so not my area of expertise.
It was
You
just
could talk about
rudi-
geometry, just not necessarily exactly what you could do with the instrument. My understanding is you can measure horizontal vertical angles.
within the XYZ.
Again, I don't think they use those
It's
terms.
a grid. It would be a grid reference system.
I'm sure they use a grid reference system. I'm pretty sure they do not use X, Y, and Z unless they're using GPS, CEF.
But
there's
what if you
perfect.
can't use, like, I work in a field where they can't use GPS, but they use the instruments and the plumb bob.
Yeah, well, you should talk to them about whether they use the terms X, Y, and Z.
Well,
You said you work with guys?
yes, and I've talked to them and I've watched them do amazing things with just a theodolite and a plumb bob.
Okay. What do they say about X, Y, and Z?
They have the instrument set up to where it spins on the X and Y, and then the Z is the plumb bob that's
Plumb
set up
bobs.
underneath it. That, yeah, and then they
And the
cite
ones
to
that
another.
they cite. Yeah.
Yeah,
Yeah, no, Buster, that wasn't my question. My question is that you said you've talked to these guys. So have you posed that question to them? Do
Well-
they use the letters X, Y, and Z when they're making their measurements
well,
with the
what would you
theodolite?
say about a plan view map? Would you say that's an XY map?
You could establish any axes you want. There's some disagreement about whether it's the XY plane or whether it's the some other plane.
plan
It depends
view?
on what. Yeah, a plan view versus an elevation view. Absolutely. You could arbitrarily
difference?
label. No, you could arbitrarily label the
Do you
axes with
think there's a
whatever
difference, Charles?
No, what's the
labels you
difference
want.
between an elevation view and a plan view?
Well, usually the plan view is overhead, bird's eye view, and an
That'd be
elevation
the
view.
X and Y.
But the thing is, and you could look it up
And
on
the
the web. There's
elevation,
different
Charles.
folks.
Would be from the X and Y to the.
But all I'm saying is there's nothing
on
about
the vertical plane, isn't it, Charles? Isn't the elevation on the vertical plane, like you said, Jesse Kozlowski and his 3 coplanar points? Would that not be the vertical plane, like elevation profiles?
So if we're talking about the elevation profile of a building, then vertical is synonymous with what do you say? Vertical is synonymous with elevation on a building.
Is
a
that
building
not
plane.
what you were saying with Jesse Kozlowski then? The vertical plane?
No, because it wasn't a building site. It was the size of a 26-mile-long bridge.
Yeah, but it's still the vertical
That was a
plane.
building. That's
right?
the building
But
site.
to get back to Buster's question
Yeah,
about
Charles,
the X, Y, and the Z.
Charles, wait a minute. The bridge was built. And Jesse Kozlowski drove over that bridge, and you said it was a vertical plane. Now, are elevation profiles on the vertical plane?
I just want to clarify
And
that
like that bit that you had in the
elevation
middle
is
that
the
wasn't
same
on that
as
horizontal
vertical.
plane, that has a
Look at the
vertical
size of a building.
elevation change, doesn't it?
Okay, so but the thing is, bobs diverge with great distance. So I just have to be very careful with my language, going beyond the size of a building site.
The building
guys like
site
to try
of
to-
the
you try-
Lake Pontchartrain Bridge.
Yes,
And the
yes,
the
that's a
vertical
bit.
plane
that's a
that
bit
Jesse
bigger. That's a
Kozlowski
bit bigger
measured
than-
about, according to you.
Oh, I'm saying that the 3 coplanar points, the plane that he's talking about is the vertical plane.
from an elevation
That
view.
plane ultimately intersects the center
like
of the Earth.
elevation profiles. So what we can do is we can plot these points on this thing like an elevation profile.
Just going to say, I'm just going to urge caution, because if you have an elevation profile of something larger than a building, then vertical and
What do you
elevation,
know,
yeah, you
Charles?
can't-
What do you know about building sites, elevation profiles, or plan views? Right, what do you know
That
about
isn't-
that?
I know enough to discuss
Because
it. Just
you're,
as
well, you're
Buster was
urging
talking about.
caution, right? Do you know
Yeah,
what
because-
you're
because
urging
you guys are
caution for?
Yes,
You're the one that's
because-
claimed a vertical plane.
because the questions, Bev, the questions that you're asking only make sense if the Earth is not a globe. That's why I'm urging caution. Okay, and I know we've gone through this
Tis globe,
so
though,
many
Charles.
times.
Everybody knows tis globe. Don't worry about it.
That's a meme. Tis globe is a meme.
Yeah, but
okay, I'm talking about the actual
everything-
spherical shape of the
Everything
planet.
that we do in reality will prove the real globe, right?
That there are hills and valleys. That the Earth is not.
No.
flat. I get that.
This what we're doing right now will prove the real globe, because this is Jesse Kozlowski, right? What do you think he's been doing?
When you say the word globe, you mean the meme. You don't mean the shape of the Earth. Okay.
No, I just mean
So, it's just-
to prove, right?
It's
The
actually-
proofs within reality will
what you're-
prove reality to be the real globe, right?
Okay,
Everybody
so when
knows
you say-
that where we live is the real globe, the real globe. So Jesse Kozlowski's measured a vertical plane, according to you. I mean, you're the one that put those 3 coplanar points on a vertical plane.
Well,
And
if you
we
listen to
know
him,
that
that's
in
what he talked
reality-
about.
Well, did he? I
So,
don't know.
Bev,
No, he
Bev,
just
when
said
you
3
when you say
coplanar
the real
points.
globe, indicating something that is not a globe, you are practicing sophistry.
What do you mean? What's not a globe?
And you are saying the phrase "the real globe,"
Yes.
and what you have in your
What's up with the
mind
real globe?
is not a oblate spheroid.
What do you
then you
mean?
are
What do you
practicing
mean that
sophistry.
what I've got in my mind? Can you hear the words, Charles?
Yeah, I hear the words, and
Yeah.
you're practicing sophistry because you do not mean the oblate spheroid.
The real globe.
I know
mean,
the Earth is shaped.
I mean, the real globe. Whatever the real globe is, will be proved by
You
facts
keep
of
using,
reality.
you keep
that
using
prove
the word globe.
Yeah.
Keep using the word globe. That's sophistry.
What you think it's sophistry to use the globe? The
No.
real globe.
I thing is, I know the Earth is a globe, and you dispute
Yeah, everybody knows
Okay.
it's globe.
No,
Everybody knows it. Charles.
No, I'm not talking about a meme. I'm talking about the actual oblate spheroid shape of the planet.
Yes,
Okay?
everybody knows that. Now,
No,
can
everybody
we get
does not
to
know that.
What do you mean everybody doesn't know it?
Oh, if you were to poll the people who are just in voice chat, do you think the Earth is an oblate spheroid?
The real globe, everybody knows here, right?
Don't change the language. Change the language.
Well,
Don't
globe,
say tis
what's up with
globe.
globe?
Tis globe. Everyone knows tis globe.
Yeah,
Because
what's up with
that's a
globe?
meme.
The
So,
globe's a meme.
If we
Okay, fair
tis
enough.
globe is a meme.
Charles.
Right? Tis
Charles
globe is a
says
meme.
that the real
and it is a
globe is a
sophist
meme, and people should stop using it.
Tis globe is a
Is
meme.
that because you
So-
want the flat Earth, right? Your flat Earth math.
My channel is dedicated to the math and science of the flat Earth debate, and it always has
Flat
been.
Earth debate.
Yes.
The maths
I
and science
was
of
using-
flat Earth debate. That's Nathan
was
Oakley. Why
using-
don't you
I
go
was-
over there then?
Because I used that
dedicated a
language
channel
before
to the flat
he
Earth
made
debate.
his
Nathan
channel.
Oakley and all of those guys. I bet they're proud.
His channel called Flat Earth Debate was created after I made my channel. So I can't help that he took the name, but it's the words that I used in my description.
So you use flat
For-
Earth first.
I used Flat Earth Debate in my description
Yeah.
before Nathan Oakley created his Flat Earth Debate show.
Yeah. So
That's what I'm
Nathan
saying.
Oakley, inspired by flat Earth mathematics.
No, I don't think he even
in
read
order
the
to
description.
make a debate thing, right? Because he probably wanted you to be part of it.
Oh, he did not have anything. He's had very choice words. Me, most of them profanity. But anyway, I think the thing is, it's very interesting to hear you talk about the Greek scholars and thinkers and rhetoricians and
No, we were
philosophers.
talking about Jaren actually, Jaren and Nathan Oakley.
No,
and
but what I'm
their,
saying is
the angle.
if you take a look at the description of sophistry, every time you say "tis globe" is an example of sophistry. So it would be nice if you would not say that because it muddies the water.
Sophistry in what way? Go on, explain.
Muddies the water.
Well, because when I say globe, what I mean is the actual oblate spheroid shape of the planet Earth. And you
How
can
do
have
you
a
use Cartesian
desktop globe
coordinates
to
on
model
that?
it. Sorry?
How do you use Cartesian coordinates on that?
You usually don't. I mean, the ECEF
They
coordinates are can be mapped over the globe. That's why, the ECF. That's why Jesse Kozlowski said 3 coplanar points, because you have an X, Y, and a Z, but they're
That's Cartesian coordinates.
yes, Cartesian coordinates. The center of the X, Y, and Z is at the center of the Earth. Okay, and then the X-axis
like the
points
0,
out
0, 0 point.
0, 0, 0. That's
It's right
center
in the
of
middle.
Earth. Right. And then the North Pole and the South Pole are on one of the axes. I don't remember which.
Are you sure?
That's
not
the
how it
prime
works,
meridian. Right, the prime meridian, where it intersects the equator.
Is Z?
That's another one of the
Is
axes.
your Z-axis the vertical?
I can look it up.
Charles,
The axes of the ECEF.
is your Z-axis the vertical in your X, Y, Z?
No, because vertical is not defined in global geometry.
In Cartesian coordinates?
No, yeah, vertical is not defined in Cartesian coordinates.
Okay. Well, when you do a graph and you use X and Y in your mathematics classes,
Oh, like
at
as an
school.
algebra teacher, sure. You could say that the y-axis is called vertical on that
Okay.
sheet of paper.
right?
Absolutely.
So when you
That's-
go to the Cartesian
you do it all the
coordinates
time.
and you have X and Y, you have that as the horizontal plane, and you have Z as the in 3 dimensions, right? They have Z as being the vertical.
you could do that, like with computer graphics, people do that all the time. But you can't say ECEF and then call one
I'm
of
not
those axes
saying
vertical.
ECEF, Charles. I'm saying X, Y, and Z, the Cartesian coordinates. The XY is the plane, and the Z is the elevation.
So, as I
The
said earlier,
vertical datum, as they call it.
okay, but as I said earlier, you could name any axes to be anything you want, anything that is
Yeah, but
convenient for you.
in the Cartesian coordinates, we have X, Y, and Z, don't we?
Yes, and those letters do not correspond to anything in the real world
Yes, they do.
until
The
you
XY,
make it so.
the XY is the horizontal, and the Z is vertical.
No.
No. Yes.
No.
Yes, not unless you've said it. Not unless you say, "Hey, here's the plan of this building, and we're going to say the XY is the level plane of the first or the ground floor,
Horizontal.
and the height of the building, 10-story building, that goes in the Z direction." You could say that for a building.
Yeah, you do
But
that. I mean, that's what they do.
But you could also have planned some different set of coordinates, a different orientation.
What, of the horizontal?
You could pick that to be the XZ plane to be the horizontal for your building if you wanted to.
Are you sure?
Of course.
You
Like
mean
my
you could
understanding
just-
is computer
you could just
graphics.
label the axis wrongly.
You can label it however you want. Like, for example, I think we've talked about the computer graphics example. On a computer monitor, the X and the Y are the plane of the monitor. So the
Yeah.
Y-axis is actually
but when you're
vertical
doing
on your
plans,
monitor. The,
right,
the
your
Y-axis points towards your
elevation
ceiling.
is always vertical,
No, you're not listening to
and
me.
your plan is
In terms of-
always horizontal.
But you completely ignored everything I just said.
Well, no, I was
Computer
just pointing out
graphics.
to you. Yeah,
In
we
computer
know that. We've
graphics-
got depth of field. Yes, we know that.
Right, and the depth of field is usually the Z-axis because
I
the
told you
Y-axis
that.
points to the ceiling.
Got
and the
told
X-axis
that
to
by
the horizontal.
your
Hey,
top guy, right? So don't worry.
Hang
about
on.
So,
Hang
but what
on.
I'm saying is, it's
Flat-
arbitrary. You could
Charles.
label them however you want.
Hang on, Charles.
Sure.
I look at a map every day, and it's a plan view map.
Okay.
Now, that plan view map is from a horizontal baseline, but it's hanging vertical.
Right. So we could play games as to whether something's vertical or whether. Yes. I totally get you.
You're looking at it, it's hanging on a vertical wall, but it's a plan view map, and everybody knows looking at it
Yes.
that what it is.
Yes.
It's the X and Y.
Well, yeah. Most
Grid
maps
system.
that I've seen, at least in this country, they label one of the axes with numbers and they label the other axes with letters. So they talk about grid square, C3, and everyone knows, you go across the C column and then you come down 3 squares. So most maps I've seen are not labeled
We have
with X and Y or
Northings
Z.
and Eastings, right? In the US, do you have that? Because we have grid coordinates in the UK.
But I'm not a surveyor, so I cannot say anything intelligently about
Don't
this.
say about a surveyor. The maps. You've seen a map in America, have you?
Yeah,
Right,
yes,
right.
and I
So
am not
those
a
maps,
surveyor,
you've
so I
just-
cannot talk
no,
about
like
grid
you've just
coordinates.
said,
Okay,
square.
I'm just letting you know.
I
do
heard
not
you,
know about
Charles.
these things.
Charles, I just heard you say square about the maps in America.
Yes. Like
right?
for
Now,
example,
then-
I
so
used
the
to have a map of
question was-
Philadelphia.
So
that
the
was labeled
question
with
was
letters and numbers.
Yeah, so the question was northings and eastings. Is that what they call those perpendicular grid squares
I have
that
no
you
idea.
said they letter them?
No idea.
Okay, so are one of them north, pointing north?
It depends on if that's convenient. For example, in Philadelphia, a major street that runs sort of north-south is called Broad Street,
Not
but that does
Charles,
not run
Charles,
exactly
listen to me.
north-south.
You're talking about the
So-
streets. I'm talking about
Okay,
the
yeah.
grid
Yeah,
lines.
no, all right, but if
Charles.
you actually listen to what I'm saying, Bev, I am answering your question. Could you just listen for a moment?
Okay.
If you look at any street map of Philadelphia, they will have Broad Street oriented, quote unquote, vertically on the map. They'll have Market Street oriented horizontally. But Broad Street does not go north-south. It is a few degrees off of north-south. It's like 10 degrees off.
One vertically and one horizontally.
No, on the map, hanging on the wall. That's why when I'm using horizontal and vertical, I'm saying the map is hanging on the wall. The height of the map is Broad Street goes up and down on the map as it hangs on the wall. Okay, and that's how the map is designed. You have and you'll have grid squares on this map, and those grid squares do not correspond to north, south, east, west. That's the point I'm trying to make.
Sure?
Is it depends on the map maker.
Okay,
depends
well, I was
orientation.
thinking that you have northings and eastings.
Don't know anything about northings.
No, hang on. Our maps are hanging on a wall vertically, and it's a grid system, and they absolutely have northings and eastings.
Well, I don't know anything about northings and eastings. All I know is that
Those
the
grids,
vertical
the squares.
orientation,
It's a grid
vertical
system, and,
orientation of maps of Philadelphia, because Philadelphia was one of the first cities in the United States that was actually planned with a grid system. I just posted it into text chat.
Okay,
so that big orange line, the big orange line that goes underneath Broad Street, that's called the Broad Street line.
It looks like the Underground, London Underground.
Yeah, and these maps were inspired by the London Underground.
So is that north then?
No, it is off of north. In fact, might be. Let me see if I could find a better one that actually has the. This one doesn't. All right,
ours like we name our tunnels like they're such and such south.
I'm trying to find one that has.
Like we have a plan view just like that, but like our conveyor systems are named after the direction.
Right.
What
the thing is,
what do you think about north, south, east, and west, Charles? Do you consider them perpendicular?
Absolutely.
Okay. So it would make sense if you had squares for them to follow that north, south, east, and west, right?
Well, but you run into problems in that. I don't know if you've seen the maps of the Great Plains where it's like, hey, it's flat land. Why don't we just have a bunch of squares? Well, the squares, like lines of latitude, aren't the same length.
That's why they use northings and eastings, Charles.
You can't. Oh, okay. And I don't know what that is because I'm not a surveyor.
You don't know what northings and eastings are.
I do not know what northings and eastings are.
You know the grids you have that you're talking about, the square.
But they can't be perfect squares. That's the point I'm trying to make. They can't be perfect squares
they are
because
squares, though they're grid. It's a grid reference system.
Well, the problem is, I mean, if you're talking about like a shopping mall, sure. But if you're talking about a map that covers all of the UK, a map that covers an entire US state, then they're not squares. They cannot be squares because lines of latitude are shorter as you go northwards.
The grid squares can't be squares. Did you just say that?
All I'm saying is, and I don't know how surveyors talk about grid squares. You know, the word square.
Yeah.
If the left side of that grid and the right side of that grid, if they both are considered north, then that cannot be an actual square.
But yeah,
it has to be more of a trapezoid.
They have a grid reference system, and one of those lines of the grid is north.
Yeah, and I don't know about the grid reference system.
And the other one goes east-west, because they're perpendicular. That's
all I'm saying is that if you have a large map, the size of a country, the size of a large
like the UK
US state,
or is that
the size of a map of the
country?
UK? Yeah, absolutely. Because the UK, I don't know, it's like 10 degrees of latitude from north to south, or at least 5 degrees of latitude north to south. Probably 5.
Entirely. What we've got is we've got an elevation vertical datum from one point down south, and all of the elevations are referenced to that, and we also have a square grid system across the entirety of the UK.
And all I'm saying is that if you have a grid system made of squares,
and we also
then the left side and the right side of those squares cannot both point north. That's what I'm saying.
And they're labeled as north.
They can't both be labeled north.
All of them.
Not if they're actual squares. If you have them not be squares.
It's a grid reference system, yeah.
Well, you're just repeating yourself. The grid reference system that you're talking about
Yeah,
in the
squares.
UK,
Yes.
they could label them with the word square and have the word square not mean a geometric square. Then you could have the left side of that grid and the
Sorry?
right side of the grid both point north. But if you want to have a geometric square, they can't both point north in a grid map of the UK. Can we try to find one? Can you post one in chat? I'm just going to type grid map of UK. See what I come up with.
Yeah, you'll find that there is a grid reference system that goes out through the entire UK, and you can get maps for different areas and of different scales.
And again, I'm not a surveyor. I just literally did a Google search, and this is called grid reference map. I don't know if this means anything. I don't know if this is official or not.
You can get them all labeled.
But do you see how the dotted blue, the dashed blue lines, like where it says North Atlantic Ocean? See that blue line that goes, towards the top of the map from the North Atlantic Ocean. Do you see how that is deviated from the black lines? Again, I don't know if this is an official grid of anything.
We've got a grid for the map.
Right, but do you see that the lines that are pointing north are deviated from the actual grid, the actual black and white grid, or the black lines of the grid don't line up with the blue dashed lines that point to the North Pole?
So you're saying that the black line isn't north, pointing north?
Yes, absolutely. Those black lines on the map I just posted are not pointing north.
But that's what you do, right? When you get a compass and you do orienteering, you orientate the map north to the compass.
Yeah, absolutely. I trained on that. I trained with the old-fashioned military compass. I did land navigation across the not across the United States. I did land navigation in California. I did it in New Jersey. I did it in New York State.
Then?
No, what I'm saying is I'm very familiar with land navigation.
And I'm telling you again, I'll tell you again, you put north, the compass, along those black lines. Are you saying that's wrong, Charles?
I'm saying like the black line that goes through Ireland, that goes top and bottom on the map, to bottom, that goes through Ireland, that is not pointing north.
But when they get their maps and they all put north on the map, they line that black line up on the map, the grid references with north.
Right. Well, what I'm saying is you would not use this map, the map I posted in chat. You would not use that for land navigation. You would have
because all of those individual squares have their own grid, and they will all fit to that grid.
Right.
And you always orientate the black lines north.
Well, I'm just saying, if you see the black line that goes through Ireland, it goes through the R of Ireland. That black line is not pointing north. Okay, and that's clear because there's a blue dashed line that is pointing north.
You can say whatever you want, Charles. I'm telling you, right? Wait a minute. In the UK, when you get a map and you're doing orienteering, you put the compass and you line those black lines up to north.
Okay, so those would be different black lines than the black lines on this map.
No, that's what those black lines are. They have their own grid references, and you can find all of the maps for the UK aligned to those grids. And any one of those maps that you would pick up, you can orientate any one of those lines to north on the map.
Okay. SE asks, north is not north in Ireland. No, SE, if you look at the map that I posted in chat, there is a very faint dashed blue line. That dashed blue line points to the North Pole. That's what I'm saying. So yes, they do have north in Ireland. They can tell where north is.
The geographic North Pole, right?
The actual North Pole of the
right.
Of the
so
Earth.
Not the compass north.
Well, compass north would be the magnetic
lines.
North, which would be you'd have some sort of magnetic declination. It would be off by a little bit.
That's what you do. You orientate your maps to the compass, and those are black lines. That's what you do.
No, those black lines are absolutely not even magnetic north.
So you're saying it's wrong then? Anybody doing an orienteering and doing that
Oh,
where they align those
I'm
black
saying,
lines to north? You're saying they're doing the
Bev.
wrong thing.
No, Bev, I said nothing of the sort. I said
Okay.
that the map that I posted in chat of all of the United Kingdom is not used for orienteering. You would have a much, much smaller scale map for
Yeah.
orienteering.
But all of those black lines would be in the same orientation because
No.
the grid, yes, Charles, the grid
They
that
would
you
not.
see on the screen for that particular map is just broke down into smaller scale.
No.
Yes.
Well, I mean, yes, but the thing is, they would indicate where. I don't know. Look up a grid map of Ireland. That would be very interesting.
I've got a
Just
grid map,
trying to.
a few grid maps of the UK, right? It's just over the
Yeah,
other side.
but the one that is the closer you are to Greenwich, the closer you are to the Greenwich meridian, the black grid line will line up, pretty
that's
closely.
why they all line up north then, right? That's why we have the grid system in the UK. We're with the originators of it, probably because all of the grid lines were actually north, right? So that's what I'm saying, Charles. I'm saying practically when we
the
talk
grid lines
about
are all
them,
not north.
well, they are.
No, they're not. I mean, can't you see what's happening in Ireland? What do you think that blue line is doing? The one that passes through
Charles,
Ireland, the blue dashed line.
Are you saying that the grid lines that point north aren't pointing north? Is that your claim, Charles?
My claim is that the blue dashed line is pointing north. All of the blue dashed lines are pointing north on the map that I posted in chat. That's what I'm saying. Where do you think the blue dashed line is pointing? The one that passes through Ireland.
The blue lines are. I'm telling you, the black lines are the ones that you orientate your compass to, north.
But you're not using this map to do orienteering. That's what we just said. That
you're not using it to do orienteering either.
You would use a much smaller scale map.
But all of the
really
black lines on the much smaller scale map are still orientated the same as those black lines there, Charles. You claim to be a maths teacher. What don't you understand about the grid system in the maps?
I understand that the North Pole is where all lines of longitude converge. So,
right.
Bev,
Charles, let me say it again. Is that the compass north? Is that where compass north points to that?
No, compass north is magnetic north.
When we orientate our maps to the black lines, right, they're not orientated to where you say the blue lines are going to. Is that correct?
Yeah, they're not.
Can I orientate my map in orienteering to north by the black lines then, like I say we can do?
No. The closest you have to a 0 degree magnetic declination, I just posted something, is in the southeast of the UK, has a 0 degree magnetic declination. All these lines are not these lines do not point north. They're just saying how far off magnetic north is from grid north.
Okay.
Probably confused.
If we were try work out in the America, right, where you have northings and eastings, which are pretty similar, I'd say, to the grid lines in the UK. Would you say they're not?
Well, the problem is that they're square. They can't be squares because lines of latitude get shorter as you go northward.
We're not talking about lines of latitude, Charles. We're talking about northings and
but lines of latitude are east-west, 100%.
Oh,
okay. So if you take a look at Kansas, I just posted it in chat. If you take a look at Kansas, the left side of Kansas and the right side of Kansas, they look like they're pointed inward. So basically, because the left side of Kansas and the right side of Kansas follow lines of longitude, right? And literally the state gets less wide as you go northward. Of course, there's that rough area in the corner. I'm not talking about the rough area in the corner, but just the part that looks vaguely rectangular, the lower half of Kansas. Right? Those lines are all oriented towards I wanted to say grid north. What's it called? Geographic north. The North Pole. Left side of Kansas, the left border of Kansas is geographic. It's the Kansas and Colorado. The Kansas-Colorado border on the west side of Kansas. That points to geographic North Pole. The right side of Kansas, that's where it borders, what, Missouri? That also points geographic north. Does this make sense? And those two lines are not, that's not parallel, it's because the lines of longitude intersect at the North Pole.
Oh, perpendiculars. Are they perpendicular?
And everywhere, like literally every town in Kansas, you're going to have north, south, east, and west perpendicular to each other. Absolutely.
Mhm.
The lower left corner, that blue county, you've got a line of latitude and a line of longitude. In the lower right corner, the green county, a line of latitude, a line of longitude. Those are perpendicular. But those two lines that point north, they are deviated. They're deflected from each other. Not parallel. And I think that was the point that I forget who was making. Was it Betty was making the point that, on a map, you have two lines that are perpendicular to another line, then
Yeah, Betty's perpendicular proof.
Yeah. But does that make sense, Bev?
What, that you're trying to shit all over Betty's perpendicular proof?
No, everything Betty said was correct, but he was asking a question that was aimed at somebody who does not know the Earth is a oblate spheroid.
Yeah, no, he was doing perpendicular.
Well, he was doing perpendicular.
Like, what we could do, we could put he put longitude and latitude, but like you've just said, the north, south, east, and west are perpendicular. Absolutely. So you could just replace one of them with north, south, and the other one with east, west, couldn't you?
Yeah, but he was being more specific with lines of latitude and lines of longitude. So one line of latitude, and then, for example, the bottom of Kansas. The south border of Kansas, that's a line of latitude, and then he has two lines of longitude that are separated by a distance. That's the point he was trying to make. That's why he used latitude and longitude. Sorry,
north south.
Latitude points north south. Absolutely. But the point he was making is that if you're looking at the Kansas map, I got the Kansas map on my screen. Looking at the Kansas map, the southwest corner is that blue county. Those are right angles. That line of longitude meets that line of latitude. That's a right angle. The southeast corner of Kansas, where there's that the green county, the lower right, that's a line of latitude meeting a line of longitude. That is also perpendicular.
Yeah.
Right?
Yeah. So would you agree with Betty's perpendicular logic then?
Well, no. And I think what he's saying is that if the map, if the Earth were shaped more like if all horizontals are parallel, is what I'm trying to say this very gently. If all horizontals are parallel, then theoretically, his point number 3, all lines of longitude would have to be parallel to each other if they're both perpendicular to the same line of latitude.
Yeah, like north and south, like we did. Let's spell this out. North-south is perpendicular to east-west. Right? Two lines, e.g. north-south, perpendicular to the same line, i.e. east-west.
Yes.
Are parallel to each other.
No. Well, not in the real world.
Oh, well,
it would be...
You're having to go at Betty's logic then, right?
No, Betty was trying to poke his finger in your ribs. Playfully.
That's perpendicular logic.
Well, no, only
like
if
mathematically, right?
Only if it's a plane. Only if we're talking about a plane.
Mathematically, we're talking about perpendicular, aren't we?
For
your flat Earth mathematics, right? So
no, I'm not. I'm Charles.
Mathematically, if east-west is perpendicular to north-south, then does that not make them parallel, like Betty says?
No.
Does it not?
Because the line of latitude is actually a curve. That's the part that he was trying to get you to acknowledge.
No. Perpendicular.
I get that, perpendicular, but the actual line itself is a curve.
So
when
north-south.
When you construct another
Is
perpendicular,
north-south perpendicular to east-west?
yes,
Okay, now
the line,
is
the
it
line of
okay?
latitude.
Is it okay for you to have two lines north-south perpendicular to the same east-west?
Yes,
And
absolutely.
then would
That's the
that
whole
make
point.
would that make those two north-south lines parallel?
Only if the line of longitude, only if the line of latitude were a Euclidean straight line, which it is not. That's the point he's trying to make.
East-west.
That's why he's poking his finger in your
Are you
ribs,
saying the
tiki, tiki, tiki.
east-west, or are you changing it back to
I'm saying
latitude?
east-west
Right, well,
the line of latitude that goes east-west. If that were a Euclidean straight line, then yes, north-south on the left side of Kansas would be parallel to the north-south line on the east side of Kansas. However, the line of latitude, the line that goes east-west, is curved. So when you make
okay, so
a
you
perpendicular
can't have
to
it.
it on the west side of Kansas,
So you're
Curved
saying your
in
initial
which direction?
Yeah, your initial statement of north-south being perpendicular to east-west was a lie, right? Because
north-south is perpendicular to east.
but you've just said that east-west is a curve.
I'm saying that the line that traces east-west is a curve. Yes, absolutely.
Well, how can it be perpendicular then? Because perpendicular is the relationship of two straight lines to one another.
That's only in your definition. The whole rest of mathematics disagrees with you. That's the thing that
Are
this
you
whole
sure, Charles?
Aporia, imaginometry. Didn't you invented imaginometry, right? You're the creator of it. In imaginometry, you can only have perpendiculars between straight lines. But in the real world of actual geometry,
That's
you
a
can have
subversal.
perpendiculars. You can have perpendiculars between curves and straight lines, between curves and curves, right?
But not
and
between
that's
vertical and horizontal, right?
Well, let's leave aside those labels out of it. We're focusing on north, south, and east,
You're
west.
saying you can have perpendiculars to straight lines, to curves, to circles, and all of that, but not to vertical and horizontal. Like that's
So
fucking ridiculous, Charles.
Okay, if you insist,
you're a joke.
If you insist,
you are
you can say,
a joke that has been led by a model. Like you're the most model obsessed person I've ever fucking known. You're a joke.
You just asked a question. You won't let me answer.
No, because you just fucking
plumb.
said something so stupid. I can't believe it.
Vertical is
You
aligned
claim
with
to
plumb.
be a mathematician.
Vertical is aligned with plumb. Do you agree with me?
Wait. Vertical is aligned with plumb. Like this, I asked this earlier. This was like 30, 40 minutes ago.
Yes. Vertical is always aligned with plumb.
Okay,
Anything
wait.
you construct perpendicular, vertical, to a vertical plumb bob. Anything you construct perpendicular to that will be horizontal.
Okay, here we go. All right, perfect segue. I'm going to construct a theodolite perpendicular to plumb.
You mean the horizontal plane of a theodolite perpendicular to plumb? What you meant?
That it's in the instrumentation. It actually is called a horizontal plate. Like that's what you get.
Yes, I understand.
Yeah. So it's I'm going to construct that horizontal plane at azimuth on that in that theodolite underneath a plumb that's vertical. Okay.
Yeah.
All right. Perfect. It has a crosshair in the sighting, right?
I've never looked through one, so I'm not. I know there's a crosshair in an auto level. I don't know what it looks like in a theodolite, because the theodolite you could elevate the telescope. You could point to the dipper if you wanted to. So I just don't know the technicalities of the crosshair business.
That's the whole purpose of. You said you had excellent critical thinking skills.
I do.
I'm highly questioning that right now.
No, but here, Buster, you have to understand. In an auto level, there is a little prism that is hanging on a little pendulum, so that you are pointing at sort of at the horizon, or if you're pointing at a distant object, you have a little crosshair, and if you adjust your auto level slightly up or slightly down, the crosshair will No, it will still point to horizontal, even if you are moving your instrument a little bit.
There's a crosshair and a theodolite too. That's
But
the whole
but
point of.
here's the thing with the crosshair and the theodolite is the crosshair and the theodolite is my understanding is that it is not like the crosshair in a auto level, and that it doesn't show horizontal. It actually shows you're targeting for a vertical angle measurement. So you could point it up at the top of a building, right? So you can have a crosshair and you're pointing at the top of a building. You're angling your theodolite up at the top of a building or the top of a hill.
So,
Okay.
So you
Again,
can't.
I am
you
not a
can't set it
surveyor.
to-
I have
you can't
never
set
touched
it
the
to-
theodolite.
You can't set it to 0, 0. Like you like you set the instrument up properly. You can spin it. You can you can hang it a plumb bob directly underneath it.
Yeah,
There's a
I
crosshair
get that.
in the reticule of it. Like that crosshair that's in a theodolite is not meant to represent how you've set it up properly.
Okay, so we never got to your question. I just wanted to clarify that just want to be careful with the language. So, but let's get to your question about this theodolite that is oriented. The horizontal plane of the theodolite is horizontal. It's perpendicular to vertical.
Is the crosshair in a theodolite meant to represent that perpendicular properties?
I don't think so. And again, I'm just
Why
going off the
not?
top of my head. I've never touched a theodolite.
Why?
So
You said you were excellent at critical thinking skills. Like, this is baffling.
So you tell me, Buster. A theodolite was an instrument designed to carefully measure horizontal and vertical angles, which means you could literally take a theodolite to downtown Philadelphia and you could angle it up and point it at the top of the nearest skyscraper.
I'm talking about
I'm
the
hoping that
rudimentary-
you would say that crosshair is not perpendicular to plumb.
The whole point of setting the instrument up properly is to get it to a 0, to get it to
Yeah, I
the
get you.
lined
But
up.
if you're elevating the telescope like at a 45-degree angle,
No. Not wait. Before you eat, we're talking about first principles here. We're talking about
Okay.
setting the instrument up. This is like we're talking about reasoning skills. The whole point of having a crosshair in the reticule is to set the instrument up properly so that the vertical and the horizontal crosshairs are aligned. That's the whole point of setting it up. Like that's the 0.
and just I hope you're patient with me. I have literally never looked through a theodolite, and I have no, practical knowledge, or even I have never even read about how you zero a theodolite. So
Okay.
if you're asking me questions about the crosshair, I cannot answer those questions.
Well, you were
Okay.
more than willing to talk about the crosshairs in an auto level, but you're not willing
Yes,
to talk
because the
about one in
crosshair in an auto level,
in
I
a-
know for a fact is aligned with a little prism that has a pendulum, which means it is aligned with plumb. So the crosshair in an auto level is a horizontal projection of your horizontal plane at your eye level.
Well, how would you ever know you're measuring angles with a theodolite if you don't know the first principles of how to set it up? How would you ever know what angle you're getting if you don't know you've set it up properly?
No. Okay, so I think we're talking past each other. Presumably, the person who is setting up the theodolite knows what he's doing. So let's say the theodolite is set up correctly. All I'm saying is don't ask me about the crosshair. I don't know what the crosshair in a theodolite does, other than you could elevate the telescope 45 degrees, in which case the crosshair is not, it's not horizontal, unlike an auto level, right? I don't know what the crosshairs do when the telescope is horizontal. I don't know. I've never touched a theodolite. I've never read a theodolite manual. Okay, so that's why I'm just saying. As long as you're not asking me a question about how you set up a theodolite, I don't know how you set up a theodolite. I know it's supposed to be set up properly, but I don't have technical knowledge, and I think that's kind of what you're getting at. It was this crosshair business. I don't know. Okay. I've got lots of critical thinking, but I literally don't know how the instrument works. Right? So other than it is used to measure horizontal and vertical angles if it's set up properly.
It's the same crosshair that references vertical and horizontal to get to get what you call vertical and horizontal angles. That's what those crosshairs are meant for.
Yeah, but I don't know
Yeah,
anything
but
more than that, right? Because like so when you look at the crosshair, it is perpendicular to plumb. I don't know it's perpendicular. Why would it be perpendicular to plumb?
because you set
Right?
the instrument up properly.
But what if the telescope's at a 45-degree angle? You're no longer perpendicular to plumb. That doesn't make any sense. The theodolite's designed to measure vertical angles. You're pointing at the top of a
How do
skyscraper.
you know you're measuring a vertical angle if you don't know you've set the instrument up properly?
No, you set the instrument up properly. However that's done, I don't know how that's done. Once the instrument is set up properly, you can make all the measurements you like. I just don't know how to set the instrument up properly. I have a
Wow.
few ideas, but I've never touched a theodolite, and I am not a surveyor. I can't just conjure
You're
up the way of
arguing
setting a
from
theodolite up.
ignorance.
Yeah,
Yeah, well
obviously.
done. Yeah.
I don't get what the question was, because it seemed to be, Buster, that your question is a technical question about theodolites. I'm telling you, I've
It's
never
about
touched
an
one.
inch. You say that it can measure angles vertically and horizontally.
If it's set up properly, and presumably if you own a theodolite, you know how to
How
set it
you're
up properly.
Yeah, like you're turning it back on me. I said that in the beginning, but now you're saying that back to me.
No. I'm saying that
Yeah.
if one has a theodolite, if a person has a theodolite,
Okay,
assuming that person knows how to set up the instrument properly, you can't
there
just
you go.
slap it on a tripod.
Right.
You have to do a procedure. I don't know what that procedure is. I've said it to you 10 times already.
So
I don't know what the procedure is for setting up a theodolite. But once it's set up, once the theodolite is set up, and you're golden. You can measure vertical and horizontal angles all day, and they'll probably be accurate. Okay? It
Probably.
just seems like what you're asking.
probably maybe.
Well,
Like, but you
within
don't know
a few arc seconds or whatever.
You just
It's
believe.
the precision of the instrument. Arc
But you
seconds.
you just believe that Jesse Kozlowski did it. You don't know how. You don't know why. I mean, he probably did it. Probably.
Well, being that he is a professional surveyor with a license that is for public record, I think that's a pretty safe assumption.
You just believe him.
Well, I have no reason to disbelieve him. Like, he's never, ever, ever said anything to me that has proven to be not 100% the truth.
You're not willing to use your critical thinking skills to work through it yourself. You just believe Jesse Kozlowski did it. It's just a
Buster,
known thing.
Buster, you keep challenging me on my critical thinking skills on the setup of an instrument I have never touched. It's like asking me about diesel mechanics. Like,
No,
I
it's
drive
not.
a gasoline car.
Would you?
I don't
No,
know how the glow
That's a
plugs
false
work.
equivocation
Right?
fallacy.
No.
That's false equivocation. Like, all I'm asking you is, are you geometrically, like, how sound is your geometry?
Very sound.
Very sound. That's the whole point of how these tools work, is sound geometry.
Yes,
And
but I've never
I asked
touched
you
it.
how you. No, wait. I asked you how your critical thinking skills were. Excellent. These tools use sound geometry. You would agree, I think, but you can't make the connection.
Well, no, what you're asking me to do is make a connection with an instrument I have never touched.
It's an instrument that has sound geometric principles attached to it.
Angle measuring. It's an angle measuring device.
Yeah, are angles geometric?
Yes, but
yes.
well,
Are they
all I'm saying is,
soundly
Buster,
geometric?
Buster, why don't we skip the part where we set the theodolite up accurately? Let's just say
That's the whole point of it.
Okay, well then you got to talk to some other guy. You got to talk to a surveyor, somebody with a theodolite.
Obviously.
I mean, didn't you say you have guys at your work site that use theodolites?
Yes.
Then have this conversation with that person.
We've already
have
had it,
this
Charles.
Yes.
Like, what you seem to be not recognizing is that we have experience in this, whereas you quite clearly do not.
Well, I've never made a claim about the shape of the Earth that was based on my using a theodolite.
Nobody is making a claim about the shape of the Earth here,
Yeah,
Charles.
but you guys disagree with me about the shape of the Earth. That's the whole
Charles,
point of
we
my
all
engagement with
agree.
you.
Everyone knows his globe.
it's a meme, and you're committing sophistry.
Right. Okay.
Right?
By saying that,
Everybody
okay,
does
fair
not
enough,
know
Charles.
the Earth is an
Right,
oblate
okay.
spheroid.
Right, can we
okay?
get back to this horizontal vertical relationship of the tool? Right?
Yes.
How do we know a tool can measure horizontal angles and vertical angles?
If it's set up properly,
Okay. So
it
we
should have
set it
no
up.
trouble.
We set it up on the horizontal plane, the azimuth, like we set everything up. Right? Whenever
Azimuthal
you've
plane,
got a
yes.
telescope or anything, it's set up on the azimuthal plane. Yes? And that way we know that when we move the telescope in the vertical position, it measures a vertical angle.
So in terms of telescopes, that's called an alt-az mount, as opposed to an equatorial mount.
Right. Well, that's what you have
Azimuthal.
with these
It's
tools.
an altitude azimuth, right? Alt-az, altitude azimuth. That's what
Say
you do with a big
azimuth.
heavy telescope.
right.
With a
That's-
lighter
well, that's exactly
heavy
the same
telescope,
as an auto
use
level,
a EQ
and
mount.
that's exactly the same as a telescope, right? And exactly
Okay.
the same as a theodolite. So now
Okay.
you're a little bit wiser on how the tools get set up.
If you handed me a theodolite, I probably would not set it up correctly. But it is
No,
possible that I might be getting
you
a
have
theodolite
to
in the near
actually
future.
have practice in doing that, setting it up. Right,
Yes.
but that's not
Okay.
what we're saying.
Yes.
We're talking about
Okay.
the principles of how they work.
Yes.
Right.
Sound geometric principles. Yes.
Right, okay,
Measuring
so-
angles on the horizontal and vertical. Yes.
Okay, so that's what Buster's talking about. So there's no need for you to now say that you've never done it, so you don't know. We're talking about the mathematical principles of horizontal and vertical, and I
Right.
know for a fact, Charles, that you have a problem with perpendicular.
You're lying, because I have no problem with perpendicularity.
Okay,
What's
well,
he lying about?
You
perpendicular?
just said I have a problem with perpendicularity,
you
and
do.
that is the opposite of the truth. I
Beddies-
literally wrote a comment to you
Beddies-
today. I have
Beddies.
no problem with perpendicularity.
Okay, so Beddy's
For you to say I have a problem with perpendicularity is a lie.
of what we just went over with north, south, east, west, you curved one of the lines.
The line of latitude is curved.
Right, so that can't be perpendicular then, can it?
Only if you use the try-thinking on the level definition of perpendicular,
No,
which is not
no, no.
the definition the rest of the world uses.
We're using the definition from Euclid.
Euclid
That's the definition that we use.
Euclid. Okay, that's not a definition.
Yes, it is.
Euclid
It's
described.
a definition number 10. But
Okay.
one. Do you want me to get it? I'll get it
Okay.
for you, right? You're saying it's not a
you remember-
definition because you're...
You remember when Blue Marble Science said dead cats don't make sounds, dead dogs don't make sounds, therefore dead cats are the same as dead dogs, right? That's what he was talking about. If you have two straight lines crossing each other and it makes a right angle, that is called a perpendicular. That does not say that you cannot repeat that procedure with a curve in a straight line, or with a curve and a curve. There is
It's a
nothing in that
of
definition
perpendicular.
that is not the definition of perpendicular. That is
It is, that's what it
identifying.
says. The other is called a perpendicular.
So
to
show me where in that definition it says that nothing else can be called a perpendicular.
Wait a minute.
It's not there.
Two curves meeting.
Yes.
What is that?
They meet at an angle. The angle can be measured.
What's
You
an
add
angle?
up all four
Wait,
angles.
Wait.
they'll add up
You
to
say
360.
two curves meet at an angle. What is your definition of an angle?
The orientation of where one line or segment, I'm trying to be careful with my
Orientation.
language, meets another line or segment, line or curve, right? It's an orientation of where the two meet. You can have acute, you can have right angles, you can have obtuse, you can have all sorts of angles, but you will get, if you have two lines or curves, or one line and one curve, doesn't matter, they cross each other, it forms four angles. Those four angles will add up to 360 degrees. And that's where you get the joke of the tiny protractor. If you don't know what the angle is, you're not using a small enough protractor. That's the joke.
Plane rectilinear angle is the inclination of two straight lines to one another, which meet together but are not in the same straight line.
Yeah, so why don't we not call it a plane rectilinear angle?
Well, that's the
We
definition.
just call it an angle.
Sorry, Charles.
Call it any old thing we
what do you want me
want.
to do?
Oh, notice the
Is it
phrase
upsetting to
rectilinear.
you? Is that upsetting
No, it's
to
not.
you that it's...
Didn't you just say plane rectilinear?
Yeah, that's the definition, Charles.
Okay, of a plane rectilinear angle. How about we have a definition of an angle between a curve and a straight line, or an angle
about
between
you
a
do
curve
that?
and a curve?
Like, you think you can
Sure.
do that?
Oh, Euclid lived 2,500 years ago. And the amazing thing to me is that some people, I'm not naming names, but some people think that geometry stopped development when Euclid died. There has been no development in geometry in 2,500 years.
Who's that?
I will
Wait,
say Euclid
Who's
was a
that,
giant.
Charles?
Euclid was a giant. I'm not
Who-
naming names.
Who thinks there have been no changes? Is it changes in geometry or
I'm saying
developments?
Developments, advances. For example, Euclid lived about 2,000 years before calculus, right? And guess what? Calculus, every calculus
Is
book
calculus
I've seen.
geometry, Charles?
Okay. Here, I'm pulling off my calculus
Charles,
book.
is
literally
calculus geometry, Charles?
It uses geometry extensively. The title of every calculus book I've seen is called Calculus and Analytic Geometry. Okay, it is literally in the title of every calculus book I've ever seen. Calculus and Analytic Geometry. And guess what?
does
Calculus
that
was
redefine
invented 2,000 years
perpendicular,
after
Charles?
Euclid.
Does that
Sorry?
redefine perpendicular?
Does not redefine perpendicular.
Oh, well, so
Nothing
the
nothing in
standard
definition
still
10.
stands then, right?
Definition 10 is not exclusive. There is nothing in definition 10 that says you cannot apply the word perpendicular to any other situation.
It's only the foundations of geometry, but I mean, hey,
So,
like you've got
okay, so
got a different definition somewhere. I
okay,
suppose.
all right. I'm gonna challenge you, Bev, and you're not gonna like this very much. So you're gonna play along for a few moments. You're looking at definition 10. It's on my screen, the one you posted in chat. You looking at that?
Uh-huh. I posted it.
Okay. So Bev, would you agree that you can have a plane perpendicular to another plane?
Absolutely. Definition
Well, according to
3,
definition 10, you can't.
No, definition 3, book 11,
No.
I think.
Just saying. If
Plane.
we're looking at definition 10, and it says nothing about a plane being perpendicular
because
to another
this is
plane.
book 1, Charles.
All I'm saying, Bev,
Book 11,
there
you
is
want to be
nothing-
looking at if a plane
Bev,
perpendicular
Bev,
to a plane.
Bev, you can't stop talking over. All I'm saying is
just-
there's nothing in definition 10
Yeah, but I'm just pointing out to you,
that
Charles.
is exclusive.
This is the first bit of geometry, the conceptual part. You want to be looking at book 11. Solid
Bev,
geometry
you
for
were
a plane
holding-
perpendicular
you were
to a
holding-
plane.
You were holding, Bev, you were holding a definition 10 as the definition of perpendicular, yet it doesn't make any mention of planes. My point,
No,
Bev,
it doesn't need
is that you can
perpendicular.
extend-
Isn't, Charles? Is
you
it?
can extend the definition
Perpendicular
of
is the
perpendicular line.
relationship of a straight line to another straight line.
Yes,
Not-
but not to a
not-
plane.
Yeah, but
not to a
you
plane
can
to another
have those
plane,
straight
apparently.
lines within planes, can't you? You
Doesn't say anything about a straight line within planes.
Charles, you can have both of them in the same plane, or you could have them both in different planes. And have
Where does it
the
say that in
planes
definition 10?
perpendicular.
You're just making this stuff up. Doesn't say any of that in definition 10.
I thought geometry
Bev,
was like a stair step. Is it not a stair step process?
It is. And you guys
It is.
stopped
Okay,
the
wait,
stair
wait.
steps 2,500 years
Four,
ago.
Sorry, definition 4.
It's stair
you
steps
guys
to where it's
stop-
proof
you guys
on
stop-
proof on proof. And you're wanting-
Absolutely.
Oh wait. Oh yeah. Okay. You say absolutely, but if you stair step proof on proof on proof on proof, and you want to stop at step 3 and say doesn't say this, well, you just haven't gone to 3, 4, 5, 6.
So Buster,
You're-
I hope you know, I was teasing Bev when I said it said nothing about planes. I agree that planes can be perpendicular. I'm teasing Bev because Bev was holding up
What do you mean
definition
teasing?
10 as the
Are
definition.
you all right, Charles?
I am perfectly sane and happy and
Right. Well,
whatever. Okay.
like your teasing is ridiculous because it's not really teasing. You're just making yourself look fucking ridiculous. It's
Says
like you
you.
don't even know about Book 11.
Says you. Well, no, I am not a Euclid expert. I know extensive
Obviously.
amounts of geometry, but I am not a Euclid expert. Because guess what? Euclid died 2,500 years ago. Okay.
Yeah.
And the
But that's just
when
where
I
you
was
get your
teaching
definitions and your understandings, the
when I was
basics.
teaching high school
There you go.
geometry,
Book 11, definition 4. A plane is perpendicular to a plane when the straight lines drawn in one of the planes perpendicular to the common section of the two planes are perpendicular to the other plane. See,
Right.
it defines it there
so-
for you. Like,
okay, so thank you for looking that up. But
Yeah.
Bev, I hope you understand my point. Is
you were
that the
teasing me. I
definition?
understand that
I was
you were
teasing you.
childish teasing when you didn't understand the basic concepts of geometry, Charles. It's
My
rather
goodness
embarrassing
gracious.
for somebody claiming to be an expert in it.
What's very telling is the fact that you can't let me finish a sentence without talking right over because you know exactly what I'm going to say. But that's okay, Bev. This is your
I
show.
don't know
This is
what
your
you're going
forum.
to say, Charles. I don't give a
You
fucking
just
fuck.
won't let me say it. It's all good. Hey, I've been here over an hour. I really appreciate the hospitality. And Buster, it was good to speak to you again.
Yeah.
I hope to get my hands on a theodolite in the near future, maybe in a matter of months. So
Okay.
I hope to learn how to use it.
If you do, just learn how to set it up properly. The whole crux of it was sighting to a plumb bob string after
Yeah.
setting up properly.
Yeah. Well, I'll have to learn the ins and outs of that because like I said, I know more about the mechanics of a auto level than I do a byte. So
Well, let's take an auto. Wait. Hang on, just real quick. You got an auto level. It's got a crosshair. You'd say it's set up properly. The crosshair in it is
right. The auto
horizontal
level,
and
it's on
vertical.
a pendulum. The crosshair is in
That's
a little
fine.
pendulum prism.
Yep, perfect. What if you sighted to a plumb bob string?
Oh, meaning yeah. But the furthest plumb bob string you'd be able to sight is no bigger than a building site. So you're not going to have any problem there.
It would line up perfect.
Yeah, it would line up perfect. I mean, even if you
Yep.
could sight it in a plumb bob that's 69 miles away, the only thing you would see is it leaning away from you, and you would not be able to detect it leaning away.
Leaning away.
Yes. Because
What
plumb
about if
bobs
somebody's,
diverge one
what if
degree per 69 miles.
what if you set one up and I've got one just like you and I set it up properly, but I sight to the same plumb bob?
Yeah, it'll appear oriented properly vertically in both of our sites. I'm just saying because the auto level, even if you gave it
What about if I do one as well?
it will look fine to all of us because the auto level, the crosshair on the auto level, the vertical. I'm
But you
assuming
said
it's
it
got a
was
vertical
leaning
crosshair.
away from someone.
Right, leaning right, and you cannot detect leaning away with a crosshair on an auto level.
What about if somebody else is looking at it? Would they not be able to see it leaning away?
It would not be able to. It won't. It would be leaning away equally for all people who are equidistant from that auto level or from that plumb bob. And you wouldn't be able to detect it. Yes, because it would be because any instrument would
Yeah, I
share a
guess you
vertical
struggle
plane
with
with that
perpendicular,
plumb.
don't you?
It just sucked over my answer. Any instrument is sharing the same vertical plane as that plumb bob.
Okay.
And if you have,
even if we're
50 people.
perpendicular, like if I'm perpendicular to you and Buster's perpendicular to me, and we're all looking at the
The
same
same
plumb bob,
plumb bob.
Yeah.
Yes.
and we're all
It-
perpendicular to the plumb bob.
I don't know how you'd be perpendicular to a plumb bob. But what I'm saying is, let's say you, Buster, and I were all 70 miles away, let's say 70 miles away from this plumb bob, and somehow we had a 10,000 power telescope on our auto level.
Okay.
Well,
Well,
we would
just
not be
you
able to
and Buster,
detect it
right?
leaning away.
Let's say you are looking at your plumb bob, right? Yeah.
Yes.
Now
yes.
you say it's leaning away from you.
At the degree of 1 degree per 69 miles.
Okay, like we had
That's
that before.
that's what
I've
people
already
joke
done a
about
meme
lean
of that.
away.
Right. Okay.
There's like a meme
what
about
then?
buildings leaning
What about
away
if
and
we
stuff.
send Buster perpendicular and him
Doesn't matter.
to look at the plumb bob that's leaning away from you?
It's also leaning away from him because the Earth is a globe. So no matter
So it's
what
leaning
direction you go.
perpendicularly to each of you.
Well, no, not perpendicularly. Any auto level.
Well, it must
Any
be.
auto
If it's
level
leaning
and
away
the-
from Buster and it's leaning away from you, and you and Buster are both perpendicular to the
Right,
plumb
like say
bob,
one's
then it
north
must
and
be
one's
leaning
east.
perpendicularly to itself.
No,
Yeah, it has to
Is-
be logically. Critical
No.
thinking, Charles. Switch it on.
no.
Come on.
What you're assuming? See, you've got model affliction. You're assuming that we're standing on a flat baseline, and we
No,
are
no.
not.
I'm assuming
Standing on a
you're
curved
looking
baseline.
at a plumb bob.
Yes,
This is
but I'm
reality.
looking
Okay,
at
and
it
then
on a
I'm
globe.
sending Buster to perpendicular to the plumb bob, right? Because that obviously, if you can see the plumb bob, then there's a straight line from you to the plumb bob. So
And
we
let's say I
can
was
have
69 miles away.
perpendicular, right, to that plumb bob
Let's
from
say I
that
was due
line that
east.
you've got, and we could send
Right.
Buster to that position.
Let's see, he was due south, right? I'm due east of the plumb bob. He's due south of the plumb bob.
Like
and
we
we're
had
both 69 miles
perpendicular
away.
before, but didn't you curve one of those earlier?
Let's just talk about what we're talking
So
about
I mean,
right
no,
now.
we need to know: do we have the same understanding of perpendicular, or are you going to edge in a
North.
curve somewhere?
North is perpendicular to east. Okay.
Okay,
So if I go,
but you're not going to bend east-west, are you?
I am not bending east-west.
Right. So east-west does not bend in this scenario when
Well,
we've got
no.
plumb bobs.
So, all right. Let's say you're starting at the plumb bob, and you have a.
Just have a straight
could say
line
a
to
compass.
the plumb bob. Doesn't
You
matter.
can have a compass.
You don't need
You
to
can point.
orientate it at all, right? You're
No,
just
you-
looking at the plumb bob.
but
There's a straight line
okay.
from you
You
to
literally
the plumb bob.
interrupted when I was trying to explain after you asked me a direct question.
Yeah, because you're
So
going to
can I-
start
can I
fucking
continue?
about with orientations. I was just
You
asking
wanted
you
a 90
whether
degree.
you have a problem with
You
perpendicular.
wanted a 90-degree orientation, did you not?
Perpendicular, yes.
Okay. So if you're at the plumb bob and you point your finger due east and you say, Charles goes 69 miles in that direction, and I go 69 miles in that direction, and then you point your finger due south and you say, Buster, 69 miles in that direction.
Uh-huh.
Are we agreed that that is a 90-degree angle? Okay. And we are
Well,
both
but you
69 miles away
pointing?
from the plumb bob. Sorry?
Are you pointing?
No. You were standing at the plumb bob, pointing east and pointing south. And so I travel east 69 miles, and Buster travels south 69 miles,
Okay,
making
that's because
a
we
right
know
angle.
that north, south, and east, west are perpendicular.
North, south, east, west are perpendicular.
Okay,
Yes.
so now
Are,
we've got
are we
a plumb bob.
now? Are we now established?
Yeah,
and now we're
now
looking
we
at this
understand. You're
plumb
both
bob.
looking at the same plumb bob.
Plumb bob. And
Yeah.
what I'm saying is the plumb bob string will
Yeah.
be leaning away from Buster at 1 degree. It will be leaning away from me at 1 degree.
Right, so
I'll also
but you
be
can't
aligned
notice the
vertically.
sideways tilt of
It's
it.
0 deviation sideways.
Okay, so are
Right?
you
0 deviation sideways.
are you going sideways 1 degree then?
I am not going sideways. I've
How
got
come-
an auto
How
level that
come
has a
you
vertical.
can't see the tilt of Buster's plumb bob, and
Because we're
Buster can't
standing
see
on
the
a
tilt
globe.
of your plumb bob?
Because we're standing on a globe.
Well,
and so the plumb
Okay, well
bob,
that makes sense, right? It's a nonsense, right? That obviously makes sense. That's obviously tis globe. That's a proof.
that's, you've
right
got
there.
you've got
Thank you
model
very
affliction
much.
there, Bev.
No,
got model
that is
affliction. You can't
that's
see
a
it.
proof from you.
Can't
Thank
you
you.
can't see it because you've got this model in your mind that it's not globe.
No,
Right?
no, I just said it has to be globe, right?
That tis globe is a meme, okay? And it's a sophistry meme.
Yeah, but you've just
But
proved
if-
it is globe, right? You
Okay.
you can't see the tilt of Buster's plumb bob, and Buster can't see
No,
the
no,
tilt
no,
of
your
your
plumb
plumb
bob.
bob.
No. Buster and I do not have plumb bobs. You have the plumb bob, and both of us are 16 miles away from it. One's east, one's south.
Uh-huh.
Okay. The vertical orientation of me and my auto level is the same as the vertical plane that is in the plumb bob is in. Likewise, Buster has a vertical plane that is passing through him and his instrument. It also is passing through that plumb bob, right? Neither of us can see the tilt of the plumb bob because it's directly leaning away from us. It doesn't deviate left or right. It is tilting away from us exactly at 1 degree per 69 miles. And that is how celestial navigation works. It's every degree of angle of elevation equals 69 miles of distance, or 60 nautical miles if you're on the ocean.
Man, you made a
It
full
only
circle.
works.
That's
It
awesome.
only works if you're on a oblate spheroid.
Tis globe.
Oblate spheroid.
It's the only way it could happen, right?
Oh, I think Askin is
it has
upset
to be.
that J-Ro invited me.
Yeah.
Anyway, so I don't want to monopolize your time. Thank you for the invitation, J-Ro. I really appreciate the conversation, Buster. Appreciate it, Bev.
Yeah.
Thanks for hosting. And I'm hoping to get my hands on a theodolite in the next, like, say, 2 months or so.
You should
So-
see how far you can actually see with it. What sort of
I don't-
angle you
can't
can
see-
measure over a
you
certain
can't-
distance.
Yeah, you can't. You definitely can't see 69 miles, at least to a plumb bob. But
No, but
it's always great.
What you should do is just check it over about 500 meters and see how accurate you can see the angle measurement.
Yeah, that'll be interesting.
Yeah.
All right, gentlemen, thank you very much. I hope you guys have a great evening and a great weekend. Oh, today's Friday. Yeah, hope you guys have a great weekend.
Yeah. Okay.
All right, take care. Bye bye.
See ya. Oh, it's 4:15. Amazing conversation. I think we had Matthew Learns in as well. It's like a sort of semi-mathematician. It's been a night of the mathematicians.
Yeah.
Well, I mean,
So I'm still amazed by the like 3, 4, however many people can cite to a plumb bob, and it lines up,
it's
but
leaning away from everyone.
it's leaning away. Yeah.
I think
It's
if you get
fantastic.
if you get 4 people all perpendicular to each other, right?
Mhm.
Obviously,
He did agree to the perpendicularity of northeast, south, and west.
Yeah.
and-
so you could get it to lean both towards and away from you in every direction, couldn't you?
Guess so. That's amazing.
Yeah. I think I
I'm-
think we might update it, right, and make it a T section, right? Because you could be at the, like you're the guy in charge, and you're looking at the plumb bob,
Mm-hmm.
right? And then somebody says it's leaning away from you, and you go, right, John, go that side over there, and Bob, go that side over there.
Mm-hmm.
So you've got 2 people now, both sighting their plumb bob from perpendicular.
Mm-hmm.
Now, they can't see your tilt, yet, according to you, it's tilting both to the left for John and to the right for Bob. And you can't see either of them either. Makes total sense. I mean, 'tis globe.
It makes total sense.